Welcome back to Solve It with Sir Jude. Last time we talked about quadratic function on how are we going to determine if a given equation, table of values, ordered pairs, and graphs are considered as quadratic function. But today we are going to focus on rewriting or transforming quadratic functions written in standard form to its vertex form. So what are the things that we should consider when we are transforming quadratic function written in standard form to its vertex form? So the goal of this video lesson is for us to transform quadratic function in standard form to vertex form. So recalling the standard form, it is given by y is equal to ax squared plus bx plus c, wherein the variable y can be replaced by f of x, which is also equal to ax squared plus bx plus c. So they are just equivalent. So this form should be written in these forms or in the vertex form given by y is equal to a times the square of the binomial x minus h plus k. Just like the standard form, replacing y by f of x, they are just equivalent. So why is it that this form is considered as the vertex form? Simply because we can easily see, determine, and identify the vertex of the graph when we have this form. Y is equal to a times the square of the binomial x minus h plus k. So the vertex is given by the ordered pair h, k. So we should also consider that when we talk about the vertex, it pertains to the highest or the maximum point, and then or the lowest or the minimum point of our parabola. So how are we going to transform? So there are two methods in transforming quadratic function written in standard form to its vertex form. So we have the completing the square method, and then the second one is using the formula of h and k. So let us first have completing the square method. So we need to transform y is equal to x squared minus 6x minus 7 to its vertex form. So we should take note that this is in, or the given quadratic function is written in its standard form. So to do that, the first thing that we should consider is to separate x squared minus 6x, or the quadratic term and the linear term, from the constant term. Okay, so let us put them in one parenthesis, x squared minus 6x. Again, the quadratic term and the linear term. Next, we need to factor out the value of a. And if you can see, the value of a here is 1. So therefore, if we are going to factor out, the terms inside the parentheses will remain the same. Again, if the value of a is 1, the terms inside the parentheses will remain the same. So, and then, we need to complete this part of the quadratic function. We need to make it a perfect square trinomial. So how are we going to make this a perfect square trinomial? So the first thing that we should do, just like in completing the square in solving quadratic equations, they are just quite similar. So the first thing that we should do is to get the value of b. So in this case, the value of b is negative 6. Then, we need to get the half of it, or simply divide it by 2. So negative 6 divided by 2, that will give us negative 3. And then, this negative 3 will be squared or multiplied to itself. So negative 3 squared, or negative 3 times negative 3, will be positive 9. So 9 will be added to the expression inside the parentheses to make it a perfect square. Now, if we are going to add something or a term inside the parentheses, we will be subtracting a term outside the parentheses. The question is, what are we going to subtract? So to determine the term that will be subtracted to the term outside the parentheses, the thing that we are going to do is to multiply the value of a and the term added inside the parentheses. We just need to multiply. So that will become 1 times 9. 1 times 9 will give us 9. So this 9 now, or the product obtained, will be subtracted to the term outside the parentheses. So therefore, we now have the equation or the function y is equal to 1 times x squared minus 6x plus 9 minus 7 minus 9. And if you can see, this is a perfect square trinomial that can be factored as a square of a binomial. So to obtain that, we just need to get the square root of x squared. So that is the first term of the binomial. So we now have x. Then we copy the sign of the middle term or the linear term. So that will become minus. And then to get the last term of the binomial, we need to get the square root of the last term of the perfect square trinomial. So the square root of 9 will be 3. And then square it. Then, we need to simplify or combine negative 7 minus 9. So negative 7 minus 9 will give us negative 16. And if you can see, this is already in vertex form. Since the value of a here is 1, we can rewrite it as y is equal to the square of x minus 3 minus 16. Okay? The value of h is positive 3. We have here negative 3. We need to change the sign to get the value of h. Thus, we have h equals 3. Then, for the value of k, we just need to get or copy negative 16. And if you are going to combine 3 and negative 16, we can now obtain the vertex of the parabola that lies at 3, negative 16. So this is now considered as the vertex form of y is equal to x squared minus 6x minus 7. We will now proceed with the second example. So we need to transform y is equal to 3x squared minus 6x plus 2 to its vertex form. So this time, if you can see, the value of a here is not 1. Okay, not equal to 1. So it is 3. How are we going to do that? So it is very easy. The first thing that we should do is to separate the quadratic term and the linear term from the constant term. So that will become y is equal to 3x squared minus 6x enclosed by parentheses plus 2. Then we need to factor out 3. Since we are going to factor out 3, what will be the terms inside the parentheses? So for us to get the terms inside the parentheses, we will be dividing the original expression 3x squared minus 6x by the value of a. Okay? So simplifying this one, this will just be equal to 1. So therefore, the first term inside the parentheses is x squared. Next, 6 divided by 3 will give us 2. So therefore, we now have minus 2x, then plus 2. Since we already factored out 3 to the original expression 3x squared minus 6x, we now obtain y is equal to 3 times x squared minus 2x plus 2. So just a reminder that when we are factoring out the value of a, in order for us to determine the terms inside the parentheses or what is left in the expression, we need to divide each of the original terms to the value of a. So in this case, the value of a is 3. So therefore, we need to divide each of the original terms in the given expression by 3. The next thing that we should do is to complete the perfect square trinomial. So what should be added to x squared minus 2x? So to do that, we need to get the value of b. The value of b is negative 2. Again, we need to get the half of it or divide it by 2. So negative 2 divided by 2, that will give us negative 1. Then this negative 1 or the quotient will be squared. Multiply it to itself. So negative 1 times negative 1, that will give us positive 1. So this one will be added to the terms inside the parentheses. Next, if we added a term inside the parentheses, we will be subtracting, again, a term outside the parentheses. So the next question is, what are we going to subtract? So to determine what to subtract in outside the parentheses, the thing that we should do is to multiply the value of a, which is 3, and then the added term, which is 1. Okay, if we are going to multiply 3 times 1, that will give us 3. So this 3 now will be subtracted to that term outside the parentheses. So if that will be the case, we now have y is equal to 3 times x squared minus 2x plus 1 plus 2 minus 3. Then we factor out this perfect square trinomial. The result should be square of a binomial. So to do that, we just need to copy the value of a and then get the square root of x squared. The square root of x squared will be x. Okay, then to obtain the operation inside the parentheses in this binomial, we just need to copy the sign of the linear term. So that will become minus. Then, to get the second term of the binomial, we just need to get the or extract the square root of 1. So the square root of 1 will be 1. And then, we need to combine 2 minus 3. We now have negative 1. So we can now say that the vertex form will be y is equal to 3 times the square of the binomial x minus 1 minus 1. So what will be the value of h here? The value of h, we just need to get the number and then change the sign. So this is negative 1, change the sign. The value of h will be 1. How about the value of k? The value of k will be just negative 1. We just need to copy the term outside the parentheses, which is negative 1. And if we are going to combine the two h and k in ordered pair, we can now obtain the vertex that lies at 1, negative 1. So this is the first method in transforming quadratic function from standard form to vertex form. So the next method will be the use of the formula for h and k. Okay, so let us now have an example given by y is equal to x squared plus 4x minus 5. At this moment, we will be getting the values of a, b, and c first. So that will be a equals 1, b equals 4, and c equals negative 5. So what will be the formula in getting the value of h and k? So for h, we will be using h equals negative b over 2a. For k, we can use k equals c minus b squared over 4a, or we can use k equals 4ac minus b squared all over 4a. So they are just equivalent. Okay? So but in this case, we will be using the first formula in getting the value of k. So after getting the values of a, b, and c, the next thing that we should do is to substitute. So the h equals negative b over 2a, and k, we have c minus b squared over 4a. Let us first solve for the value of h. So we now have h is equal to negative, the value of b is 4, over 2, the value of a is 1. And if we are going to simplify, negative times positive will give us negative 4. Then 2 times 1 will give us 2. Thus, we have negative 4 over 2. Getting the quotient, negative 4 divided by 2, the value of h is negative 2. Next, how about the value of k? We need to substitute the values of a, b, and c to the given formula. So we now have negative 5 because that is the value of c, minus b squared, the value of b is 4. That is why we have 4 squared over 4 times the value of a, which is equal to 1. And if you can see, 4 squared or 4 times 4 will just be 16. Then 4 times 1 will give us 4. So if we are going to simplify, we now have k is equal to negative 5 minus 16 over 4. But 16 divided by 4 is 4. So we now have negative 5 minus 4. The value of k here is negative 9. Okay, so we are now through getting the values of h and k. So if you are going to combine them together, the vertex will be at negative 2, negative 9. But we are asked to find the vertex form. So in getting the vertex form using the formula of h and k, we need to consider the values of a, h, and k because those are the variables that needs to be replaced in the vertex form. So let us now supply the blanks. So the first blank stands for A. So in our equation, or in our function, the value of A is 1. So write there 1. Then the value of H. The value of H that we computed a while ago is negative 2. And then the value of K is negative 9. So next, we need to simplify. Negative times negative will now be positive. And then positive times negative will give us negative. So therefore, we can now say that it is just equal or equivalent to y is equal to 1 times the square of the binomial x plus 2 minus 9. Or we can just rewrite it as y is equal to the square of x plus 2 minus 9. And this is now the vertex form using h and k. Okay, so let us now have another example. Using the formula of h and k, let us transform y is equal to 2x squared minus x plus 1 to its vertex form. So again, we need to get the values of a, b, and c. The value of a here in the given function is 2, the value of b is negative 1, and c is equal to 1. Next, we need to substitute those values to find the value of h and k. Let us first solve for the value of h. So substituting the values of b and a, we now have negative of negative 1, since the value of b is negative 1, over 2 times 2, since the value of a is 2. Negative times negative 1 will give us positive 1. Then 2 times 2, that will be positive 4. So that will now have 1 over 4 as the quotient. We now have the value of h, which is equal to 1/4. Next, how about for the value of k? Substituting the values of a, b, and c, so c is equal to 1, so that will be 1 minus negative 1 squared, since the value of b is negative 1, over 4 times 2, since 2 is the value of a. Simplifying, we have k is equal to 1 minus 1/8. How are we going to subtract a whole number and a fraction? So the thing that we will do is to cross multiply. So 8 times 1. The answer is 8 minus 1. Okay? So again, 8 times 1. So that will be 8. Copy the operation, that is minus. And then, copy 1. Then the denominator will be 8. So simplifying, 8 minus 1 will be 7. Then copy the denominator, 8. So we now have the values of h and k. The next thing that we should consider is to substitute the given values of a, h, and k to our vertex form. So let us now supply the blanks. So the first blank pertains to the value of a. The value of a is 2. So put 2. Next, the value of h is 1/4. And then the value of k is 7/8. So negative times positive will give us negative. And positive times positive, that will give us positive. So the final answer or the vertex form will be y is equal to 2 times the square of the binomial x minus 1/4 plus 7/8. And by the way, the vertex here is 1/4, 7/8. So it's your turn. We need to transform the following quadratic function written in standard form to its vertex form using any method. So given the following quadratic function, I will be giving you time. You can pause the video for a while and try to answer the following questions. Then, the next slide will be for the answer key. So let us see if you got the correct answers. So these are the correct answers to the given standard form. So the corresponding vertex forms are as follows. I hope that you've learned something for today on transforming quadratic function written in standard form to its vertex form. So if you've learned something for today in this video lesson, do not forget to like, share, hit the notification bell for more. The next video lesson will be rewriting quadratic function written in vertex form to its standard form. So that will be the vice versa process of what we had today. Good day!